Okay, so we've got a wave that has to travel more distance. That would be described by 2 times the thickness divided by the wavelength. So in terms of wavelengths, we're traveling 2 times the distance, or 2 times the thickness divided by 1 wavelength. So again, as I said, if the wavelength was 5 units of measure, and the thickness was also 5 units of measure, then it would have to travel an extra 10 units of measure divided by 5, which would mean that you were traveling 2 whole wavelengths extra, minus a half because of the wave inversion, or the phase shift, would mean that you're getting phase shifted by 1.5 wavelengths, which means that upon exit of the wedge, that is at this point right here, we're going to be shifted by 1.5 wavelengths, or we will have caused total destructive interference for that particular wavelength. Okay? And that's for that particular wavelength because that particular wavelength, or half wavelength, is fitting an integer number of times into the thickness. Now, it's not going to happen when it's not fitting an integer number of times into the thickness. Let's try another one. Go a little bit further. Oh, I should have said. Oh, you know, never mind. Martha's going to steal that one. Oh, okay. Oh, okay. All right, so 2t over lambda minus a half. We're going to call that m. No, this is continuation. And we're going to say that m is going to be the number of wavelengths. Okay. And so if we rearrange this to isolate for thickness, I'm just going to do it a little bit mathematically here because I don't want to show my work. Thickness is equal to 1/2 m plus 1/2 lambda.
Why did you use 1/2 lambda times m plus 1/2? Why did you do it on like
1/2 lambda.
You have like a number and then a bracket and then like another number. Why did
You want me to write it like this? 1/2.
Oh, I was just wondering, like, is there a specific reason you wrote it?
Well, lambda gets. Oh, I see. No, it's just a style thing. Could do it this way, I guess, or you could do 1/2 lambda. Fine, we could write it this way. That way, Martha? Yeah, you're right. There wasn't any specific reason. Yeah. No, m comma, where m is the number of wavelengths.
Extra wavelengths, right?
Yeah. Extra wavelengths traveled. Yeah. Let's phrase it like that. Extra wavelengths traveled. Traveled by what we called ray 2 beyond that traveled by ray 1. Okay? Now here's something that you need to remember. Lambda in the medium is different than lambda in a vacuum. Okay? And it's going to be expressed in terms of index of refraction. And we said it earlier. We said, oh, I won't pull back the sheet again. We can just say that lambda n is equal to, should be lambda over the index of refraction for that particular medium. Okay? So you have to keep the index of refraction in mind when you're calculating the thickness, because the index of refraction determines the wavelength. That wavelength right there. We should really call this lambda n, or the wavelength within the thin film. So it's nice that we have n's and m's here, where n represents index of refraction and m represents an integer multiple.